All right, the next section that we want to look at is linear functions. This comes from section 2.2 in the book. In this presentation, we're just going to review slope-intercept form and the formula for slope. All right, so you should know the formula for slope-intercept form. Slope-intercept form is the equation y equals mx plus b, where m is our slope. And when we talk about graphs, remember that slope is rise over run. B tells us the y-intercept, and if we were to write it in point form in order to be on the y-axis, we're going to write it in the form 0, b. So the first thing that we want to do in order to graph equations using slope-intercept form is we want to plot our y-intercept, and then we're going to use our slope, the rise over run, to move to at least one other point on the graph. From there we want to draw a line through the points and remember to label. So if we look at example A, we have our y-intercept is the -1, and in point form that's going to be 0, -1. So to plot that on my graph, starting at the origin, we're going to move 1 down. Now my slope is equal to 2. And when we talk about graphing, we want to think of this as a fraction. So I'm going to write this as 2 over 1. So in order to move according to our slope, we're going to start at our y-intercept. I want to go 2 up and 1 right. We're moving in the positive directions. So starting from here, we're going to go up 2, and we're going to go 1 to the right. So we should end up right here. And you can do this from any point on the graph. So for instance, from here, I can go 2 up and 1 to the right, and it continues going. Now, just so you know, slope doesn't move just one direction, you can move the other direction. So 2, I can also write this as -2 over -1. Do you agree that that's also equal to 2? Hopefully yes, our negatives cancel out, leaving us with just 2. So if we did this, this would be 2 down and 1 left. So from any point on our graph, we can go 2 down, 1 left, and we should be right about here. If you notice, they all lay on a line. And so now if we go ahead and connect our points, we should get something that looks like this. We want to go ahead and label. If we label, we have our y-intercept as 0, -1. And remember that when you label these points, remember that points are always sideways and then up and down. So for instance, if we label this point, this is 1 to the right and 1 up. So this point here is 1, 1. If we look at the next point over, we go 2 to the right and 3 up. So this is 2, 3. All right, so that is graphed and labeled, and so we are done with that example. All right, let's come over to example B. Our y-intercept in point form is going to be 0, 2. Our slope is -4/5, and that -4, you can either put it on the top or the bottom. I'm going to put it on the top. And now what does this tell me to do? Since this is a negative 4, this means I want to go down 4. Positive 5 tells me I want to go to the right 5. So if we go ahead and graph this, 0, 2 is 2 above the x-axis on the y-axis. And now if we go down 4, 2, 3, 4, and right 5, we should end up right about here. And just remember that in order to graph a line, you only need 2 points, minimum of 2 points. I have that, so now I can go ahead and draw my line. It should look something like this. We label. To get to this other point, how do we get there? From the origin, we go 5 to the right and 2 down. So this point is 5, negative 2. All right, so that takes care of graphing equations using slope-intercept form. Let's see what else we got in this section. The next thing we want to talk about is slope. Now you can think of slope as rise over run, but we also have a formula. And our formula for slope is m equals y2 minus y1, the difference in the y values, over x2 minus x1, the difference in the x values. So let's go ahead and try some examples of this. I'm going to let 10, 11 be my first point, so that's going to be my x1, y1. And I'm going to let 8, 3 be my second point, x2, y2. And you can label these however you want, as long as you remember that the first number is always your x coordinate, and the second coordinate is always your y coordinate. So if we go ahead and plug into our formula, we get m equals 3 minus 11 over y2, 8, x2 minus x1, 8 minus 10. If we simplify, we get 3 minus 11 is negative 8. 8 minus 10 is negative 2. If you simplify the fraction, you get 4. Since we're not graphing, we can go ahead and leave it as a whole number. All right, let's try one more basic one. Same thing, I'm going to go ahead and label my first point as x1, y1, and I'm going to label my second point as x2, y2. So we want to subtract the y values. We get negative 7 minus 4 over, subtract the x values. We get 20 minus 13. If we go ahead and simplify this, we get negative 7 and negative 4 combined to negative 11. 20 minus 13 subtracts to 7. We cannot simplify the fraction, so we're just going to go ahead and leave it as it is. All right, let's try some other examples that are more consistent with what we're going to see in our application problems for this course. We can work with decimals and fractions as well. But the same idea is what we're going to work with. So I'm going to do x1, y1, x2, y2. We subtract our y values, so we get negative 2.6 minus negative 3.1 over negative 1.8 minus negative 2.8. Now each of these minus and negatives become plus. And so let's see what happens when we do this. Negative 2.6 plus 3.1 is 0.5. And negative 1.8 plus 2.8 is 1. If we simplify this, this is the same thing as 0.5. Okay, so let's look at example D. Now, when working with fractions, I do write it a little bit different because I don't want a complex fraction. So what I'm going to do is this. Again, let's label our coordinates. I'm going to subtract my y coordinates, so we get y 1/6 minus negative 2/3. And this time, instead of writing it as a fraction, I'm going to remember that the fraction bar means divide. So we're going to divide by 1/6 minus 1/2. Okay, so we need common denominators. Our LCD is 6. So if we go ahead and work with this, we get 1/6. We have our minus and negative becomes a plus. 2/3, to write that with a denominator of 6, I want to multiply by 2. I'm going to do the same thing to the top, so we get 4/6. Keep it inside the parentheses. The second one, 1/6, stays the same. And we get minus. This one we can multiply by 3. So we get minus 3/6. All right, if we simplify, 1 plus 4 is 5 over 6 divided by 1 minus 3 is negative 2 over 6. I'm not going to simplify, I'm going to go ahead and do my division step next. So remember that when dividing fractions, we're going to copy, dot, flip. I'm going to leave my negative on top just because that's where I'm more comfortable with having it. Now if we simplify my 6's, I can cancel those. We're left with 1 and 1. Don't forget you still have that negative there. And so this simplifies down to negative 5/2. So when you see the problem involving fractions on the homework, don't get freaked out by it. Okay, now slope tells us lots of different things. One of the main things that it does tell us is increasing, decreasing, horizontal, or vertical. It tells us what kind of line we have. It also tells us whether it's a steep line or a shallow line. So just remember that if you have a positive slope, it is increasing. Increasing lines go up from left to right. 4 is a fairly large positive number. That tells me that this is a steep slope. 0.5, this is a pretty small number. This is a shallow slope. But they both go up from left to right. The other one that we want to talk about is negative slope. This is decreasing. So for B and D, these are going to be going down from left to right. All right, let's go ahead and we got one more slide for this presentation. The last thing we want to do is kind of play around with the equation a little bit. We're going to talk about identifying slope and y-intercept form. So if it is in slope-intercept form, it is very easy to identify the slope and the y-intercept. Remember, slope-intercept form is y equals mx plus b. Another form of linear equations that we're going to see is general form, which is ax plus by equals c. If it's in general form, you can't identify slope and intercept without doing some work. So we want to go ahead and start off with general form and talk about how do we identify slope and intercept. So the procedure in order to do this is we need to get it into slope-intercept form. In order to do this, we want to solve for y. So this is another one, solve for the indicated variable. In order to do this more specifically, we're going to move the x term to the other side using the addition property of equality. After that, we want to divide each term by the coefficient of y and simplify if possible. So if we look at example A, we have 4x minus 5y equals 10. The first thing we want to do is subtract 4x from both sides. We get negative 5y equals. Now, ultimately, it doesn't matter what order you write this in, but remember that slope-intercept form is mx plus b, which means I want my x term first. So I'm going to write this as negative 4x plus 10. And then finally, to finish this off, I want to not just divide the whole right side by negative 5, but I'm going to split it up and divide each term by negative 5. So we get y equals, my negatives cancel out in my first term, that's all I can do. In my second term, I can divide and I get negative 2. So for this equation, what is my y-intercept? It's going to be the constant term. It's going to be 0, negative 2. And my slope is 4/5. Now, one of the benefits of having it in slope-intercept form is that as you get more comfortable with this, you can kind of picture what this looks like in your head without actually having to graph it. For instance, I can draw a sketch of this by knowing what my y-intercept is and my slope is. My y-intercept, I know it's somewhere below the x-axis since it's negative. And I know my line goes up from left to right because my slope is positive. The main difference between a sketch and a graph is sketch is just a general idea, whereas a graph is precise. Notice here I have no tick marks. I'm not actually calculating my slope. I'm just going up from left to right. Okay, let's look at example B. Example B, we have 5x plus 4y equals 9. We're going to do the same thing. First thing I'm going to do is I'm going to subtract 5x from both sides. We get 4y equals negative 5x plus 9. Again, I want my x term first. And then to get y by itself, I'm going to divide each term by 4. So we get y equals, I can't simplify the fraction, so I'm just going to leave it as negative 5/4 x. Same thing for my y-intercept, my b. This doesn't simplify, so I'm just going to leave it as 9/4. Now you're probably sitting there saying, well, how are we supposed to graph that? We're not graphing it. And so we can have nasty numbers for both our slope and our y-intercept. We can still go ahead and calculate these things. We can identify these things. So what is our y-intercept? In point form, it is 0, 9/4. And my slope is negative 5/4. Again, I don't want to graph this, but I can draw a sketch. 0, 9/4, that is positive, so I know it's somewhere above my x-axis. My slope is negative, and so I know my line goes down from left to right. Okay, so let's go ahead and work the other way around. If I give you a slope and a y-intercept, can you come up with the equation? Now, if it's asked for in slope-intercept form, this is very easy to do. We have our slope. Remember that slope is the m value, and the y-coordinate of the y-intercept is your b value. So we can plug these into our formula. So we get y equals 2x plus 5. We replace m with 2, we replace b with 5. And you're done. Don't make it any harder than that. If we look at example B, same idea. Negative 3/4, that is my m. Negative 5 is my b, so we get y equals m, or negative 3/4, x, plus b, or plus negative 5 is the same thing as minus 5. So just remember, when asked to come up with equations, we're going to look at several examples of this when we get into applications. Always note, if you were given the y-intercept, it makes it very easy to convert into slope-intercept form. There's no work involved, you just have to plug in the values. Okay, so this should all be review from 114 or from your previous algebra class. There will be videos. I will post my 114 videos so that if you want more practice with this, you can go ahead and watch those. We are not done with this section. We're going to get into the new material, and that's going to be talking about application problems involving equations written in slope-intercept form and involving applications involving slope formula. So we'll go ahead and take a quick break, and then we'll go ahead and look at that.